Okay, let's use this short little sheet to illustrate a few new concepts and to talk about the binomial expected value and variance with some concrete examples. I'm going to start out here with importing pandas as PD again, and I'm going to import another function from my scipy.stats package. I'm going to import something called binomial, and I'm going to start out with my number of trials set equal to 10, with my probability of success being equal to 0.75. So shift, enter, those values are in. And so with those values in, I can now calculate my expected value and my variance. My expected value is the number of trials times the probability of success. The variance is the number of trials times the probability of success times 1 minus the probability of success. And I'll put these two separated by a column on the last line. So when I go shift and enter, it will give me, again, my expected value will be 7.5 and my variance will be 1.875. Okay. I'm going to set up a binomial table with my binomial probabilities as I did in a previous lecture. So I will set up my dictionary of successes right here. Okay, where success, my success column is going to be the list of values from 0 to number of trials. And so my binomial table will be a data frame created from the successes dictionary. Okay, I'm going to have my probability function as I did before, where I said lambda is going to be a lambda defined function x colon. So x will go to the binomial dot, okay, probability mass function of x with the number of trials, and the probability of success. And so I create a new column of this by taking binom underscore table success and applying the probability function to it. And then here on this last line, I'll put binom underscore table so that we'll see what that looks like. Shift and enter, and there it is. Okay, and so here, that's my probability table. And so I'm going to want to add a couple of lines, a couple of columns to this. I want one column which is going to be the number of successes times the probability, and another column which is going to be the square of the successes times the probability. Okay, I'm going to name that first function moment, and this is a neat little trick here. Again, it's a lambda defined function, but I put entry here. Well, entry is actually going to be the whole row that we're going to be working on. Entry of 0 is the 0th entry. So this right here, this we start counting our columns 0, 1, 2, 3, and so the 0th column is the first one. So we'll take the 0th entry and we'll multiply it times the 1th entry. And so that's the value that the function moment is going to give us. The lambda defined function moment 2 is going to take entry of 0 squared. So I take this 0 column, this first column squared, and then I'm going to multiply it again times this probability column, which we know entry of 1. Okay. And so I'm going to label get a new column which is headed moment, which I'll get by applying this moment function to my binomial table along axis 1, which means I'm going to run up and down the page, applying this to the columns of the function. And I'm going to have my moment 2 column be the moment 2 applied to the columns of the function. And so I shift enter. That's done. I want to see what it looks like. Let's take a look here. Okay. And so we see here I take 0 times prob and get 0. 0 squared times prob, still get 0. And so 1 times prob I get, okay, 0, 0, 0, 2, 9, and the same here for moment 2. We start getting some differences here when I square this. And so you see that my moment is all the products of these, and my moment 2 is the square of my successes times the probability. Okay. Now, if I've done this right, so probability times successes, this moment value, which is this, it's supposed to be the sum and in my expected value calculations. If I add all of those up, that should give me my expected value. So let's try this. Binomial table moment.sum parentheses, and sure enough I get 7.5, which is exactly what I got right here. Okay. Now if I add, now for my moment squared, remember I want to calculate the variance. Remember, the variance is the sum or the expected values of the squares, okay, which should be the sum of my moment 2 columns, but minus the square of my my mean. So this right here, my binomial table moment2.sum minus binomial table moment.sum squared. This should be my variance, and in fact it is. It's just the difference is just round off. We're off in like the billionths place. I mean, this is a close thing. It's all what has happened is just lost it on round off error.